Hello everyone, welcome to Information, the one true asset to rule them all. So my name is Emma Hooper and I'm a digital information specialist at Bryan Digital in the UK. I love information, I'm fascinated by the mechanics of it and how it all joins together to make patterns. On construction projects, I'm an information manager, but I do a lot of other things as well, including leading the IFC and COBE workstream for the BIM Interoperability Experts Group for the Centre of Digital Built Britain, and author of the ISO 19650 guidance and the BSI UK expert for ISO 16739, which is the standard for IFC. And some of you may have also read my Revit and IFC blogs. So in construction, we're all familiar with physical assets like a door, a brick, or even an entire building. And to make sure we get the right product, we specify what we want. The subject of information management is concerned with viewing the associated information as an asset in its own right and designing its structure, processes, and interoperability. And for me, because information underpins everything, it really is the one true asset to rule them all. I see buildings and infrastructure as huge containers of self-generating information, and that information is ever-changing. And as for projects, they are one big information ecosystem, which is made up of inputs, processes, and outputs. The building blocks of this ecosystem is information, and I like to think of information as a natural occurring phenomenon. It's everywhere and creates our reality. It's data put into context and interrogated by a human brain to give it meaning. And nowadays, we're constantly exposed to huge amounts of it. And as a consequence, we process a fair bit that we don't need and miss the bits that we really do. It also makes us less appreciative of it. Information is cheap and we take it for granted. And this is no different to what happens in construction. So construction, or as I like to think of it, the tangled web of information chaos. And there's two factors behind this. And the first is the people-to-people exchange of information. Outdated procurement models and passing on risk has just increased the sheer amount of organisations involved on projects, the barriers, and created convoluted lines of communication. However, I want to focus on this, the communication between technology. And in this case, even at one simple exchange, we have problems getting the right data out of one system and then into another. And as an industry, we have massive problems with interoperability. And as a result, we struggle to get our systems to work together. And for this presentation, I want to focus on the mechanics of the information itself and how the way it is formed has created this problem and how we can mitigate it. Over the years, every specialism or even sometimes company has become an information silo. They all have their own particular language, classifications and conventions. And this has developed ad hoc without consideration of the other silos and the overall bigger picture. And to join it up, that's where people come in, with our ability to read between the lines, to interpret and assume, but this introduces a whole chunk of risk. And you could kind of get away with this when projects were simpler. So to help reduce this and make our projects more efficient, as an industry, we've moved towards technology to help us. But in simple terms, computers don't like unstructured, random and varied information across so many different scenarios. The whole premise of BIM is about making as much of our information as structured as possible in a consistent way, so that technology can understand it. But this is easier said than done, because it's about converting the chaos into order. And to do this, we need to remove the silos, rationalise it, and bring the information together to see what we have. Then define what it is in accordance with logical rules, such as what the function of something is, rather than the varied nature of the English language or bad habits which have evolved over time. So let's think of some examples. So what's the difference between a schedule, a table and a matrix? Why do we call it a design responsibility matrix and not a schedule? At handover, should we call it a building manual, an O&M manual or a health and safety file? This seems to change with every project I work on. Why for shelves do we call it depth, but for worktop we call it width? Is this a bulb or is it a lamp? And what's the difference between a fixture or a fitting? And we often use these terms interchangeably, but if you read the MBS website, they're actually defined by law, but with no definitive list, there is still confusion. And there also seems to be no real agreement on what a right or a left-handed door swing is. In the UK, architects and manufacturers use the opposite terms. So our industry is full of this confusion and contradiction, and I dread to think how much time has been spent thinking about this. And this is why we need information standards more than ever. If we don't understand how can we expect technology to? The trouble is, it's like trying to put together a jigsaw, but using many different jigsaw puzzles, the overall picture becomes difficult to make out and the puzzle pieces don't fit. And if that wasn't enough, we also need to join the information up. And this is where we'll gain the real benefits, because it's the connections which gives us the insight and greater knowledge. And this will be key to everything we do in the future. What this will give us is a structured information layer for the industry. And this is what we're trying to achieve now with all the BIM standards that we have, in which people and technology can operate from in the context of a project. And when projects are put together, we should think about this in the same way as the project framework. It needs to be considered at the start before any information is produced. The problem is this information layer is hidden and most don't know it exists. As humans, we relate to things far better if we can see them, if it's tangible, which is why when it comes to information, we think of the tools first above the information itself. But information is its own thing and doesn't rely on software applications to define it. They're just tools which help to process it. And as a result, we tend to see requirements and strategies built around the applications. But since these have developed around their own language and rules, these too become mini information silos, which struggle to share information between them. And this is why we have such problems with interoperability. Everything is using its own information layer, its own unique puzzle pieces. Therefore, the information ecosystem becomes closed off from everything else. We force the supply chain into using one application, which will only be adequate for a select number of activities. And you will always need that application to access the information because the format is proprietary. The facility will probably outlive the software, and there is no guarantee that the software in the future will be able to open older data sets. But hey, this is easier in the short term. But what if we turn this on its head, flip it around and change the way we currently think? The software should plug in and serve the information, not the other way around, allowing us to access information regardless of the software used. Therefore, we put the information layer first, open it up so it's freely accessible to anyone who wants to use it, resulting in one information layer which contains all the structures, rules and language to provide consistency across the industry. So what's in this information layer? It's a mixture of information science principles, and I'm constantly rethinking this, but at an abstract level, I want to concentrate on these three areas: the breakdown of the information into its component parts, taxonomy, or the grouping and ordering of information, and ontology. For this presentation, I'm talking about it in the sense of joining it up and adding additional information. So it's not a true ontology because the semantic connections are not there, but it's a start. So the breakdown of information, and I want to be clear, this is something I've come up with to help me distinguish it better, but it's not a standard. So if we take a piece of information and analyse it, it can be described using these facets. So its format, how it's transported either physically or digitally, its form, how it's packaged up and communicated to us, a summary of its content, and this is such an important facet, yet it's one we're not great at defining. What is the purpose of the content? And the content itself broken down. And this is what imparts the knowledge and tells you what you need to know, from the words in a report to the lines on a drawing or the 3D content in a model. The structured information, this contains hierarchies of objects which themselves contain content, geometrical and alphanumerical data, all linked via relationships. Defining the extent or the detail of this content is where the majority of the complexity lies. And this is what the level of information need framework in ISO 19650 helps to do. So when we specify information requirements, we're in fact asking for information across these facets. So for example, a client might say, I want a site survey in PDF format, or it might be more detailed. I want a site survey drawing and report in PDF format, which covers roads in a 3-mile radius, nearby watercourses, and concentrates on the boundary lines. Neither of these is wrong. You only specify what you need to. It's then down to the delivery team to fill in any blanks and provide the actual information to fulfill that requirement. The thing to remember is to keep it simple and only ask for what you need to fulfill your own purposes. And more specifically, for specifying structured information, the complexity here is defining the object structure. And once you have this, you can define the extent of the geometry and the attributes and properties required. So you almost have layers within facets. And this is what we're having trouble with in industry, working out how we actually define this and how we communicate it. And without having a starting point for this, which is the same across industry, the permutations are infinite. If I asked everyone watching to give me a list of building elements, they would all be different. We would name them differently, order them differently. Then if you add in attributes and properties, we would have many different sets of information. How can we deliver projects around this, and how can technology possibly understand it? So simply saying I want BIM does nothing to say what information is actually required. And when we refer to information, we generally mix these facets up because they can be difficult to distinguish. And the way we view information is subjective. It's based on our training, our region, our environment, and our discipline. We all use different information languages, and we all want to access information from different starting points. So taking this into account, and those naming conundrums from earlier, we need something to provide order, to define what the facet and object hierarchies are, and also provide the descriptions which everyone in industry can use. One unified language which does the grouping for us to help improve communication for people and technology. And this is why we need well-defined classification in industry. And this is basically objects or things arranged by similar themes and concepts, which can become progressively more granular and can also be arranged in lists. A primary classification structure, which is defined across the whole AEC and FM industry, is critical to the information layer to provide a consistent language and structure, from building type through to spaces, right down to products and across the facets. It also starts to provide order to all the sheer amount of stuff. And it's kind of like the basic building blocks of information management. And I see it as the part which connects us as people to the information layer without having to understand the complex lower level. The trouble is, especially in the UK, we have too many of these lists, or we just try and create bespoke ones each time, bring them together, and they're structured in completely different ways. But we can just map them, can't we? Well, having done this, I really think it just introduces risk, as there's many different outcomes. So you have one-to-one mapping, which is great, but that's rare. And then there may be one-to-many or many-to-one, which may need a human to make a decision. So this can't be automated. Or even worse, no mapping at all, which is where things slip through the net. And it's not really mapping that we're doing, it's more narrowing down choice. Or if we zoom in, and because the two lists are at different levels of granularity, you're never comparing apples with apples. So the mapping is unlikely to be correct anyway. And having all these lists is great, but we need to go further. Our information is also extremely interrelated. So an instance of a pump is associated with a space and a pump type. The space is located on a building story and may be part of a zone. The story is part of a facility and that sits on a site, and the pump will also be part of a system, have detailed classification assigned to it, and also be referenced in documents. It will have basic information like name, description, ID, and properties like pressure. It might also have risk associated to it. And that's just one pump. Now think of everything else which makes up a facility and how everything interlinks. And these links or relationships are so important. And when we don't recognise these, we miss out on so much more useful information, which can make our projects perform so much better. The concept I've described in information science terms is similar to an ontology. nodes connected to others via relationships, and you will hear this term far more in the future. And I think of it as the digital heart and is what the information layer is all about. So get all this right and we have the sound basis to convert the chaos into order, logic and repeatable patterns to really get the best out of our technology. So do we have something for this already? And the answer is yes. It's called Industry Foundation Classes, and I think it is one of the most misunderstood aspects of digital construction. Some people will think it's just a file format, why is it so special? And others might think of it as a dumb 3D model that you can't do anything with. And I'll be honest, I remember thinking like that once upon a time. So I want to explain what it actually is. If you remember one thing about IFC, it should be this. It's not actually a file format. It's instead a data structure, a digital representation of a built asset. Humans see buildings and infrastructure as bricks and mortar. Computers actually see this. It's like a map which lists building elements, their properties and the connections, and we actually call this map a schema. And this is represented by the blue circle. It contains 4 important parts: entities, attributes, basic properties, which are all linked via relationships. And because it can't predefine everything, there is the option to add custom properties, so there is flexibility. It provides a data architecture for several formats. The 2 main ones are STEP, which is what we think of as IFC, because it confusingly has the IFC file extension, and XML, with these other modern formats in development. And RDF, XML and Turtle are particularly exciting as these are the formats for linked semantic data, where the relationships are basically on steroids, meaning you can gain so much more useful information from querying the data. When 2 applications can read IFC, it improves interoperability. The receiving platform knows where to look for the data it needs and what the relationships are, so it too can make sense of it. And this allows us to automate tasks such as checking, analyse large data sets, and carry out predictions across the whole project. Even if you have platforms which claim to open every file format under the sun, how do they know where to find specific data and what the relationships are to start to make sense of it? To get around this, we end up creating peer-to-peer bespoke mapping between each one, resulting in endless permutations. And of course, software is constantly being updated, so the mappings may keep changing. The IFC schema is huge. Therefore, so it can be implemented within software and exchanged, we use model view definitions or MVDs, which are subsets of the schema focused around purposes. When we exchange IFC models, we are in fact exchanging MVDs. And these are some of the official Building Smart MVDs, and note COBE is one of them. So this is all well and good, but how does IFC fit into real life projects? So in ISO 19650, we have Projects Information Standard, which is where it should be stated that IFC will be used on the project as that consistent information layer. Starting with a purpose and exchange information requirements defined, and this could be, for example, asset management, planning construction works, or costing. The pieces of information which are needed to fulfill these purposes are specified across the different facets, and for structured information by the level of information need framework, which breaks the information down into its component parts. We also need to use a consistent data structure to list the object hierarchies, properties, and relationships. For this, IFC can be used with other classification. And for the structured information, the model view definition needs to be stated, which provides the relevant data structure to exchange and deliver the information using software. So think of an EIR as a multi-dimensional shopping list for information. These requirements are handed over or exchanged to those who will deliver the actual information. And it's now the turn of the delivery side to work out how they're going to provide it in terms of the who, when, and how. A big part of this is looking at the layers of information from a container perspective and the strategy around this, taking into account responsibility, program, and software. They will produce unstructured and structured information deliverables, including IFC models, in accordance with the correct MVD, which contains only the relevant information as per the EIR. This is then issued back to complete the information exchange, where it's checked against the original requirements. And because the original requirements were defined using IFC and some of the delivered information is received using IFC, this information is much easier to check. So how this relates to models, to me, models are just structured data sets which are wrapped up in geometry. And when we author models, we're basically building up databases of design information just in a visual way. And I call these primary models, examples Revit or ArchiCAD. But we don't just use these. There are many other secondary model databases like for geometry coordination, construction planning, cost, thermal analysis, or asset management in a CAFM system, and lots more. Different parts of the primary model databases are required to be exported for these secondary uses. And this should be defined as structured information in the EIR. And in terms of IFC, this is where the MVD is exchanged. And before it is received, the model exchange is checked against the information requirements, and when compliant, it's imported into the receiving secondary application. And this completes the information exchange. And because people generally require unstructured information like drawings or reports, this can be exported from either model as the final output. However, we don't make enough use of these secondary uses which analyse, predict and simulate the design and construction, the results of which should feed back to inform the design. There is potentially so much information locked away in these primary models that we're just not tapping into. We spend a lot of time quite rightly thinking about the information clients want, but what about the information which is also required in design and construction to make better informed decisions and ultimately better facilities? And this is where we can do good by reducing the risk of things going wrong and reducing the impact the facility has on its environment when it's still in its virtual state. And no, these secondary uses aren't the job of the information manager. We don't have subject knowledge. It's the engineers, designers, planners, QSs and facilities managers to do this. It's part of what they normally do. Our job as information managers is to make sure the information ecosystem supports it and that the correct information is being exchanged to do it. So in summary, whenever you're dealing with structured information, IFC can be used so all processes use the same consistent information layer throughout, from defining information requirements, planning information delivery, the delivery itself, and then very importantly, checking. At Bryan Digital, we use IFC for all information management activities to maintain that golden thread. The more we can control and standardise the information, the more it can be checked in a more automated and intelligent way against the use cases defined in the information requirements. So to end, the information layer, however, will evolve. IFC is starting to go through a process of modernisation, and in the future will make far more use of proper ontologies, linked data, knowledge graphs and the semantic web, where these external data sources can all connect together. And this is the stuff that really excites me. This is where the concepts of the digital twin and smart city come into play. And this is why I believe this information layer very much lays the groundwork for the connected future. So I truly believe we all need to work together to make IFC the best it can be. And when we do get it right, the majority of industry won't even know that we're using it. So remember, information is the key and we must put it first. Thank you.